You know what? Let's just kick this off. Get it over with, right? It's already been one of them days, as you guys can see out there. I can't figure out my scene selection correctly. I can't seem to get, this meeting to start at the right time. You guys can hear me. For all of you out there, go ahead and let me know in chat so I know that you guys can hear me. As always, make sure you can see me as well. It's been nothing but a great week, like always. Trying to do a little organizing here so you guys can see me a little better. Bad Campers, great to see you out there. Appreciate seeing you in chat, like always. Now, how can I get this arranged where I'm not looking at the ceiling when I talk to you guys? Right? I think that's a little bit better. I can see my chat now. How's everybody's week been otherwise? Go ahead and get a little more arrangement going on here. All right, this guy's got to go here. All right, I think that's about as good as she's going to get. Brian, what's going on, man? Brian, we're going to see you in person next week. It's going to be a blast, nonetheless. I see more and more people getting in here. As you guys know, Free Support Friday brought to you technically an hour late than it originally was set. So I don't know if Cosman's out there. He was griefing me an hour ago when I realized I set this meeting up when I was all the way over in the East Coast. Currently, I live in the Central Time Zone area, so I may have set it a little early. So you guys can hear me? Everything sounds good out there? Pavel, I saw you out there. We're working on that link for you, man. Before we kick this off, guys, Fusion Phil over here, jitcadcam. We host this every week. We've even started to book our trainings and everything around the fact that we want to continue to bring this content to you. Now, if you guys don't like this time slot, feel free to let me know. I'll do what I can on my end to organize this so that it fits best for everybody and anybody so that you guys can attend live. As well, for those of you watching after the fact, if you have a time slot you would prefer, keep in mind, I may or may not get up at 11 p.m. and do a live stream special for everybody else. But go ahead and let me know. Before we kick everything off this week, of course, you guys know, anytime you want to ask any questions, curious about anything you see me do, feel free to put it in chat or use the support email link down below. As you guys know, we thoroughly enjoy any donations you guys have ever made. We have super chats. We have the Buy Me a Beer program. If you're getting a crazy answer and you really want to give more than a beer, we've also now set up the Buy Me a Steak program. So we're going to go ahead and kick this off with an energy drink. And nonetheless, I actually am going to start something new this week. So I'm not going to drink a real beer on stream, but I bought some Busch NAs. So whenever somebody buys me a beer, I'm not going to drink a beer every time you guys buy me a beer, but we'll crack that guy open once somebody buys a beer. Now, I don't want you to buy a beer just so that you get me to drink it, but I want it based on the fact that if you guys get something valuable out of this, that is the reason why we like to see it. So I'm going to go ahead and pivot, change my screen, and we actually got a pretty good part to kick things off. So this was a random phone call I got about an hour ago. Somebody was asking me, hey, we have an old seat of feature cam. I'm looking for a post processor. By the way, I'm not ITAR in any way. And with that, what we told them is, hey, we could write a post for feature cam, but dollar for dollar, you're almost better off moving to Fusion. Now, a lot of you are probably already questioning, we do video content on feature cam. We love to support the feature cam community in any way we can. But in this specific use case, it's actually looking at to be easier to move them to Fusion and then use the default post processor. So as you guys can see here, this is going to be a mill turn part. So we're going to go ahead and jump over to manufacture. And with that being said, the first thing I need to do is create my setup. Now, I don't know how many times I'm going to have to say this, but I say it a ton and I say it quite often. Everything you do in Fusion was aimed at kind of like reading a book, right? Now, we're always going to read from the top of the page down, and as I've started to say, every time you see a little line divvying something up, it's almost as if you're reading paragraphs, right? So again, we move top down, left to right. So the first thing I'm going to do is I'm going to create my setup here. Now, again, I asked this question last week, and I'm curious, does it always take a moment for the first time you create a setup to turn on? Travis, I see you out there, buddy. Nice to see you in chat. But as you can see, everything has come in. We now need to just walk down the page. Again, we're going to read our paragraphs. In this case, this is going on a mill turn, and I don't have a machine definition set up. but we're going to go ahead and swap out to turning. And then from there, you're going to notice it's automatically recognized that this part is round. Now, me personally, I might start with the Z the other way. I should add into the fact that this customer in particular actually has no sub spindle. So we're not going to do a part transfer here, but they do have a Y-axis and live tooling. So again, we're going to go ahead and move down that paragraph. I've flipped my Z-axis. X in this case doesn't really matter if it's pointing to the right or pointing to the left here. I like to orientate my stuff as in my lathe tooling is going to come back in on X. There's Steve. Steve, how's it going? He's actually the one that threw this part on here. But I like to orientate and look at my part with my X pointed away. Again, most tooling is going to come in on that X axis. Now, as we go down to that next paragraph, our safe planes, a lot of times you're not going to change this unless you absolutely need to. Again, we're going to use a reference of a chuck holding the part in the back, a safe plane, which is where all of our rapids go to right off the rip. Elijah, great to see you early for once. Usually you show up at the midway point. So again, we just continue down. Next paragraph, we're going to talk about what you want to manufacture, already selected. Lastly, if we had our fixture or our chuck in here, we could add that in. So let's go ahead and get that page turned. So as you guys can see, Fusion has automatically created my stock. Now, for those of you out there, I can't stress this enough, don't ever use relative, only use fixed side or your solid / preceding. As you can see nominally, whether or not you believe in the bald eagle increment or that other unit, we're not going to talk about that. You can see it's always a round number, right? You're going to order your stock in a nominal dimension in most cases, and we can go ahead and type that in. Now, I'm going to give this, you know what? I am going to, let's give it just a little extra. Why not? Let's go 6 1/4. And I'm going to show you guys what happens when you intentionally screw something up. But we're going to offset from the front, and then I'm going to go ahead and give it 20 on the front to clean up. Lastly, for anybody out there, our post-process menu, program name, program number, WCS orient. This is going to be, your 1 is for 54, 2 is 55. If your machine uses something other than that, obviously know that it's just going up in an increment of 1. So we've created our setup. From there, we're going to go ahead and turn the page, right? Fusion, again, is pretty much organized in most toolpaths to run through this stuff right off the rip. If I wanted to face off this part, in this case, I'm not going to because there's no reason to face this tiny little amount. So I'm going to jump down 1 straight into roughing. The biggest mistake we always see at jitcadcam is the fact that people want to go in and change a toolpath. As you guys just seen me do here, by the way, if you guys want t-shirts made up about this, I should make t-shirts, but we can hit OK, and most times the toolpath is actually going to do usually what you want it to do by default, right? So as you all can see, we went ahead and created our toolpath on our part. Now, once we create our toolpath, we can manipulate and change things because visually it's much easier to understand things like, hey, we're undercutting inside of here. I don't want to undercut. I don't want to gouge my part there. I would like to keep that profile as smooth as possible. And again, we could jump out of this menu, edit what we were doing, and because we're changing the blue lines, as you guys may or may not know, we could go ahead and turn off that grooving. And just like that, we're now coming across that profile and continuing all the way down and around. So because of the way Fusion works, and in Steve's case, Feature Cam does very similar things. This blue boundary right now is the spun profile. The yellow is the stock still left to machine. So as you can see, we could quickly just derive another toolpath off. In this case, we're going to hit this now with a finishing profile. And as again, we're just up and around our part following that same contour. Now, some of you may be curious, why are we not machining all the way up here at the flat? And the reason we're not machining all the way up there at the flat is because that is still not considered inside of our stock. It's right at our stock. If we were to change our stock size, again, we go in here. Let's say we're actually getting some 5 1/4 round material. And now we're going to go ahead and regenerate our tool paths. And from that, we should now see, 1, me in the wrong orientation. And with that, we're now going up and around and over the top of our part with both of those profile turning situations. Now, some of you are also probably wondering, hey there, Fusion Phil, we never touched the front of this part. Well, this is the fun of having control once you get a toolpath on your part. I can visually see the blue line stop at the front of my model. So if I go to my geometry, the front of my model is basically where we start from. I know I said stop. I should have said started from model front. But if we do something simple like, say, stock front, you're going to notice it's now bumped out that orange line, which signifies our profile. And now we are basically facing and OD turning all in one shot. We did get an error here for anybody that has seen our or me do a demo or our software in any way. Our lead out is being changed because if it wasn't, it would be gouging our part or slamming into this back wall. This is a yellow line, which means linking and is a rapid. We didn't want that to happen. We may need to extend again in our Z axis with how far back we're turning our part. So again, as you can see, Fusion is very quick to update based on those changes, as we've set. Now, we may want a lead out as well here. So again, we go to the lead out linking tab, and I'm going to say allow lead to cut stock. And now you can see we could do a dog tag or a little dog leg move out and get away from our part. So I see more and more of you guys coming in here at any time. If any of you guys have any questions whatsoever, feel free to throw them in chat. We also have a support email down below. Sorry, I had to check my phone as the emails are starting to roll in. But from that, before I pivot into like live tooling and milling here, Steve, I got to ask real quick on this part. I know initially you said threads. However, the way this is modeled, it's just modeled as if that is kind of like a, what's it called? Like a gripped surface. It's not actually threaded here. So if you can, let me know in chat, is it supposed to be threads, or is this just kind of like something is, actually, I know what this is. This is kind of like a plastic anchor or something, right? 1375 by 6. Is that the thread size? I'll give you a second there. And then if you know the minor diameter from that, that will also be semi-valuable. But as you guys can see, let's go ahead and change up real quick. Let's add some milling in. And we're going to go ahead and switch back to the milling tab. Now, there's a lot of ways to mill out these features. As you can see, we have some 3D areas here that may need to be taken care of. So what I'm going to do is I'm going to go straight for adaptive clearing. And in this case, he is a lucky individual because he does have a more sturdy, heavy-duty built machine. It is a DN Solutions machine. So we might be able to get away with a 1/2-inch end mill on a live turn lathe. Now, this is what I'm liking at the end of the day with Fusion, is because I have that ability to see a tool versus my part. As you can see, this is a massive part, and it's 4140 as I'm being told. And this tool may not be suffice for that. So again, depending on what you're doing or how you're trying to do this, this may or may not be the best solution for the system, but it still goes back to that same thing. As you can see, by nothing more than hitting OK on this toolpath, I am still coming in on the Z axis and wrapping around and roughing out that profile. So again, this is the great thing about how Fusion works. You guys are seeing here in real time when I turn my profile, we're already getting everything inside of here, and our rest machining for our milling strategy is automatically detecting where it should and should not go for cleaning that area up. So again, if we want to go ahead and pivot from there and start to do something that is going to involve 3Ding the surface, or maybe I want to change the heights tab of this toolpath, as you're going to see, I'm going to drag that down a little bit. Now, you could type in an offset as well, just for those of you that are newer to Fusion. But the idea is still the same, right? Get the blue lines on your part and then make those changes. And the reason why I'm relieving that a little further is so that we have room for a ball end mill to possibly blend this surface. So again, we could go back to our 3D contour in this case. And we're going to go ahead and pick a tool. Now, you could stay with the flat end mill. As you get more advanced in Fusion, you'll realize a lot of times I do swap my tool out on the fly. And for the sake of Steve, because Steve is brand new to Fusion, as you can see, you could have multiple different speeds and feeds tied to a tool. And just like the kind of feel of Feature Cam, you could easily go down and pick whatever it is that you're doing. And then your step over and step down can automatically pull from that tool. Now, I will recommend that I've seen some things coming up that is going to change a little bit of how that material library works, and it will start to feel a lot more like Feature CAM. So again, we picked the tool. As we always know, let's go ahead and hit OK and see what we're getting. Now, as you guys can see, we're only going so far down this part. And this is where I like to test you veterans out there. Does anybody know why we are only going down so far on our part? We're not going all the way down to where that chamfer is. And I will give you guys a few moments to answer. Now, if you can't guess it in the next couple of minutes, that's understandable. I'll show you why and how this is working. And in the meantime, while you guys are making educated guesses at this, I am going to go ahead and make sure, one, nobody's bought me a beer yet because you guys are animals out there when it comes to that stuff. Go ahead and get stuff cleared up here real quick on my other screen. And get the support desk pulled up. Cool. And we are back to the live stream. I don't see anybody put the suggestion in the chat, but the idea is still the same. As I tell people, you get the blue lines and then you determine what's wrong with the blue lines, right? Well, in this case, we'll go ahead and visit that here in a second, Elijah. What I'm going to do is I'm going to edit that toolpath. And because we're looking in an XY plane, the whole reason why we can't get outside of there is because we're basing the containment of tool center and a silhouette of the part. So as you can see, this blue line here is almost to the point where it is the center line of my tool, but it will not go outside of the profile of this part. So there's ways to remedy this, of course. We could go ahead and say tool outside of boundary, or we could even turn on contact point boundary, which should help remedy this situation. As you can see now, we are going deep enough in Z and 3D'ing everything out as well. We can simply go in and change our step downs. So I'm going to go ahead and pivot here once we get the step down changed. And I'm going to go ahead and limit where we're going by using rest machining again, so that we can limit where the toolpath actually hits our part. Again, as you can see, it's all now down at the bottom area. And from that, we can go ahead and switch gears into turning those threads. So in this case, I'm going to go ahead and go to turning. We're going to go down and we're going to pick thread. And from thread, there's Steve. Steve's throwing 10 in the chat already, guys. There he is. He did it. That's the beer, right? Here you go, Steve. This one's for Steve, boys. Yes, I know it's NA. I'm not going to drink a real beer on here because I'd get sloppy quick, I think. But as you can see, we went ahead to go threading. I'm going to pick my threading tool. Again, you guys are going to define this stuff over time. Where's my OD threading? And from that, again, what you're going to see is based on our geometry, we need to define a face. So if I take my own rules to heart, had I hit OK, I would get this lovely error message, which would pivot me over to the thread face that I need to select. Now, the bad news here is that the top of every one of these is a face to thread. Now, usually we don't like modeled threads inside the software. However, again, thinking about how we can filter this out, I can actually now jump over and change where we start from on the front and even how far we go back, right? So again, I'm going to go ahead and do selection here. And as you can see, by selecting that second edge, we're now threading the length of the part. And with that, we're going to go ahead and pivot over to the passes tab. Now, this is where I think a lot of people get confused inside of the software. I myself feel like no matter what I do for the dimension here, I always have the same problem. But in the world of turning, thread depth is radial. And in the world of thread milling, thread depth or diameter offset is diameter based. So we need the difference between the major diameter and the minor diameter, which, as I saw there, Steve said 1375 and 115. So we need to take those two numbers. I'm making an educated guess here. That looks like 260 divided by 2 would be 130, right? So my thread depth is 0.130. And again, remember, we're saying this based off of half of whatever that difference is between the two diameters. Or if you're looking at the machinist handbook, you'll get the radii by default in your thread height. But as you can see, the blue line actually is lining up pretty good to the bottom surface. And from that, we have our threading cycle. Now, we do need to still adjust our pitch. Where was it? 6 threads per inch. So we could do the good old-fashioned 1 divided by 6. Again, being able to type in these menus to give us our feed. And from there, number of step downs, of course. As you can imagine, you probably want to make this in a couple of step downs. This is a pretty good size part. But as you are looking, if I get my model out of the way, and we're going to go ahead and turn off the good old-fashioned spun profile. In this case, we're actually slamming that tool in the part. I thought it would physically give us, oh, it should give us the threads, but that is a tiny tool. So we're going to go ahead and update a few things here real quick. Thickness. No, we don't need thickness. We need overall width there. And then we need to change our thread pitch, of course. So again, 1 divided by 6 in this case. That should make the thread much larger, but of course it's not wide enough. And there we go. We have a much larger turning tool in place, and we can regenerate our cycle. So with that, as you guys notice, we don't have it simulated here. Let's go ahead and run the simulation on this to see what's going to happen. So now this will be the biggest difference for Steve at the end of the day, is that the simulation inside of Fusion does not have currently mill turn machine sim. But as you can see, walking through all of this stuff, we can continue. We do have some errors coming up here, so I'm always a good time. As you guys can see, we're hitting the tool. And that is our problem. So again, we're not visually going to see this because yours truly, Fusion Fill is completely destroying this machine right now. You go ahead and get my chat back down to where I was. Getting sloppy. Yeah, right? But as you guys can see, we would have to fix a few more things. Let's go ahead and edit this tool. Let's make it chatter. That's what we're going for today. It's been one of them days. Let's just go ahead and say overall length is 6 inches, and we are going to use 5.5 inches worth of stick out, right? Why not at this point? That should get that job done, and then we're going to edit this tool as well. So for those of you jumping in, I see a lot of you coming and going. It seems like you guys are getting a kick out of our new time slot. But if you have any questions, feel free, put them in chat. You could also send us a support ticket. Elijah, I'm going to get back to you here in a second. I haven't forgot about you. I am just trying to get everything updated so that we can simulate this toolpath and maybe run threads. So again, we have everything set up here. Let's go ahead. I'm going to simulate just the threads. And it looks like we should get a solid model that shows threads. 3 a.m. in Australia, bit of a struggle. Matt, what's going on, buddy? So again, let's go ahead and change a few things here. I want to get that model turned off. And we can let this run through. And again, we're going to get some red here. For those of you that don't know, that red coloring is normally you hitting the part. But because of the way these threads were modeled, they were just as rings, as if, again, this is either, something for plastic injection molding, or, you have that silicone tube that's going to slip on there. So I'm going to give this a second. I do have my accuracy turned way up. So as you guys can see, it's slowly coming through. Maybe I'll turn my accuracy down, or we will crash Fusion. There we go. Went ahead and paused it. Again, as you guys can see, we have our threading cycle coming through that part. And with that, the last thing to do, I'll leave it to you guys while I go back and read up on Elijah's information here. Need to thread mill a 632 in stainless this week. That's going to be a good one. So I bought every thread mill, but this one would, the first time using them. What's the recipe? Here's the link. Awesome. Elijah, we're going to look at thread milling. We might as well. We're doing turning here on the lathe. And the last thing we want to do, I don't see anything in chat, but we're going to go ahead and turning part. This is where we're going to part off our model. Again, we go to our library, pick your OD grooving or OD threading tool. And we need to turn that model back on, of course, so we can see what we're doing. And now this is where I would tell you guys the importance of your stock and the size of your stock. So visually right now, you guys can see, in this case, I'm not going to hit that stock, but if I was to have to do something like flip this part over, Fusion is still going to recognize this stock right here as being in the way or a problem. My dog is trying to come into my office right now, and she just barged her way in. There we go. But other than that, Steve, I hope this helps you out. Let's go ahead and pivot real quick to a little bit of thread milling with Elijah and get another file opened up. I'm trying to think what I have for thread milling. Actually, you know what? We could thread mill this on the Z, could we not? Let's go ahead and go for it. Be quick second, make sure nobody's got anything in the support channel here. Nope. All right. So if I was to shift gears, again, if you guys wanted to thread mill a feature like this, we would go back to milling, 2D thread. Now, it doesn't matter outside or inside. Again, the surface you're going to click to drive that will accordingly be either outside or inside. But the same rules kind of apply, right? In this case, it's going to be driven by whole top to whole bottom. I would possibly want to go model top here. And I would either go model top minus a distance, or if I can select a specific depth to go to, works much better for me. And then in our passes tab, this is like I told you guys, is one you have your thread pitch. Again, that's going to be our 1 divided by 6. And then a little further down, we have what's called our pitch diameter. Going to click it. And now, again, remember, this is the part that everybody confuses. We need to type in diameter, right? So as we talked about, that 260 difference, this is where I would plug that in. Now, here we go. We're going to go ahead. I know you internal thread. I figured as much. System is still the same, Elijah. So you'll have your minor diameter. That's the surface you'll use to drive it. And then from driving it, that offset will go the opposite direction. So I don't think I have a thread mill in here. Oh, yeah, we do. Now, we're going to have to edit it, of course, but we can get it selected to start with. And then as you guys can see, there is the threading cycle heliking down the part based on that actual dimension. And if I was to edit this tool, again, we go ahead and get our cutter here. And thread pitch, 1 divided by 6. And then our flute length also needs to be a minimum of 1 divided by 6. Now, depending on your thread mill at the end of the day, you may have more than one row of teeth, right? So again, as you see me try to increase the number of teeth, my flute length, of course, is errored out. So let's go ahead and give that a much larger number. And as you can see, again, terrible, terrible example. We're going to make some changes here for you guys. But you can see that it's stacking those 4 threads for the thread mill. I would need to actually update, you know, my shaft diameter as well as my actual tool diameter in this case. So again, we can bump that number up. Let's say we're going to go like 650. And then we will go 650 on the top. So as you're seeing, that thread mill looks much better now that I've edited it out. But that is 4 threads or 4 actual leads to be able to mill with. So Elijah, does that work for you? Go ahead and let me know in chat. Steve, I hope you're still there. Either that or Steve's already downloaded and installed Fusion and he's getting going. Blake, I see you out there. Bought another beer. Blake, we appreciate it quite a bit. Thank you, sir. But with that, we can go ahead. You need the crest. What do you mean by crest? To go ahead and let me know. I'll give you a sec there to throw that in chat. And I do have one more thing we're going to do. Somebody was bugging me a little bit about this. Is we've visited this. I feel like we visit this once a month, right? So if I had a part, I'm going to start drawing this here real quick while Elijah gets some information in chat. Let's say it's 1x3. And there just so happens to be a 45-degree angle here. So, okay, the edge of the single point, it doesn't come to a sharp point. Yep. So based on the information, of course, when you measure the diameter of the tool, and you will, in most cases, have to compensate in one way or another. So as you can see here inside of Fusion, I have the ability to put on wear. Again, when you're thread milling, you could use the wear setting at the controller to adjust it to get it to where it is. I will tell you, in all of my time, the best way I have found to do thread milling is to put it in there, use everything as it should be, right? So again, that 260, all of that information is coming from the thread spec call out. Now you run it and you go to put your no-go gauge in there and you're like, oh, you know what? It's still a little tight. Well, you start adjusting wear. Let's say we adjust wear by, 15, 20 thou. That's where I like to come back in the software and adjust my pitch diameter and then re-zero out my wear. Because if I had to do 100 of these, I don't want to just keep loading up that wear setting. I'm going to do that right here inside of Fusion. I will also tell you in most cases when you guys are doing this, set your pitch diameter offset to the maximum tolerance allowed. So in this case, you always have a major and a minor. Well, you want to do the distance from the max major and the minor, lowest minor, right? That helps you almost get perfect threads every single time. As for the sharp point, that won't make a difference, Elijah. Like I said, the diameter they give you based on that tool and the way Fusion is calculating this information, you're always going to have to compensate somewhere to make up for it. So with that tool not having a sharp tip, as you can see in my cutter information, again, you have a thread profile, but it's angular. There's not a thread tip radius as well. So that's why when you calculate that, it's center line G code, and then you need to define your diameter of your cutter right here inside of Fusion. How many passes for stainless? That's a good question. I would have to look up that specific tool and see what they call out for a step over or like an AE axial engagement, right? Cool. Questions? More questions? Any questions? I see 16 of you guys out there currently hanging out. 3-4. What is 3-4? I don't know what username 3-4 is. Oh, you're calling out 3 to 4 passes. I like that. In the case of this part, this is a massive part, so it may be more than that. Again, for something smaller like he was doing, I think he said he was doing something 632. 4 to 5 passes sounds about right. Cool. Let's jump back to this other part where you guys always love to watch me doodle. So the question I had received is in the event I have a part, and we go ahead and say manufacture, so reduces passes. Are you saying when you start to mill out with multiple passes? So again, as you guys may or may not know, you could do multiple passes here, and then you could adjust the step over. Now, something I think a lot of people never realized inside of Fusion is, and I can't ever remember the technical name, is your step over will actually change as the diameter gets smaller, especially working internally on stuff. So you see this when you do adaptive clearing, because when you're in a smaller diameter, you're going to overload the tool. And we'll take a look at that. Let me see if my adaptive clearing has the information here. We'll have to mill a pocket here in a little bit. We'll prep for it. We're going to put a circle on here. There we go. We could do a little milling on the top of this part. But the issue that I started to see as people are starting to talk about with this face right here is using a chamfer tool and making multiple step downs to create that angle, right? Now, as you guys know, it seems like every time I go to do this stuff, I can never remember what it is. But we're going to go ahead and fix size box this up. And with that, there's a lot of options to try to achieve this. Now, some of you know in 2D Contour, you have the ability to do multiple depths. And then with multiple depths, we can do that with a tapered wall angle, right? So as you guys can see, is if I wanted to do a taper of 45, that is also my chamfer. And I'm going to go ahead and go grab a tool to try to attempt this. This is where, like I said, I always mix this up, right? So if I go in and I try to do this with a spot drill, if I could find a spot drill in hole making, and let's get the big one out. What you're going to notice is in the passes tab, it does allow 45 and it does allow maximum step downs to be set. But when I hit enter, of course, I forgot to grab an edge. So let's go ahead and grab that edge real quick. And we're going to get an error that says multiple depths not supported. So how do we remedy that? So as you could do is we could go back and try a different tool. Now, again, I was asked about using an engraving tool, right? So again, as if we say hole making and we come in and we try to find, obviously I can't find it because that's a milling tool, an engrave / chamfer mill, right? So again, we're going to grab a different tool here. We're going to hit OK. And as you're going to notice, it's not doing the multiple step downs now, right? So if we go back and we take a look in our passes tab, multiple step downs has actually completely removed itself because this is a chamfer and or engraving tool. So again, if we even turn off chamfer, we still don't get multiple step downs. So what do? We have to find another tool. Now, if we go in and we build a tool, and that's what I'm going to do for this. Actually, we're going to go ahead and copy that flat end mill over. And let's put that on the entitled. So if I edit this tool, what I'm going to do is I'm going to go ahead and go to my cutter. And then this is going to be a tapered mill. So this is where things get a little screwy for some people, because here I can set an angle, and you could actually set an angle of 45. And as you can see, we now have a 45-degree angle for milling and chamfering. Now you could still adjust things like based on your radius in the corner. Those things are all still editable. Maybe you have a 0 here because, again, you're kind of lying to Fusion at the end of the day about getting that information set correctly. So again, is we can go 0 here, I believe. That's right. You can never go 0. And usually your spot drill or whatever you're using is never actually 0 either. Going 0.35, as you can see, also reduces it. Understandable in this case, guys, that the shank or the holder in this one would be off, but we could always edit and change that as well, adding a holder in or adding a shaft to be able to fit that all. The idea still is the same as what we're really trying to shoot for and make happen is that ability to do a 45-degree step down following that angle and utilizing the center line of the tool, right? So in this case, I said 0.35 is the diameter, divide by 2 puts me on center here. And now we're stepping down that surface based on what we put. Stuart, great to have you out there. I see you out there, buddy. So again, I did that with a tapered end mill. I set it to 45 and we stepped down that wall. Another one we could have used in this case, some of you may have a shell mill as well. And that shell mill is another tool that will actually follow that 45-degree chamfer. Now I can set an angle on that shell mill. Again, as you're seeing, it's 45-degree step downs using 2D contour. And with that ability, we can edit that tool. Again, we go into our tool, we have our cutter. As you can see, we have a taper angle of whatever that is going to be. Again, we can add to 45. And once we regenerate, it of course will align itself. Under chamfering with a dovetail or a double angle. Yeah, we could look at chamfering underneath the part, right? So if we needed to cut underneath this face with a different Z, again, what I'm going to do is I'm going to create a new setup, of course, because we need our Z axis pointed the other way. And now, again, if I was to use 2D contour, I can set my 2D contour based on the bottom edge of what I want. And in this case, I'm holding my Alt key here. Now, I do need to be cautious of starting off of the part far enough that we don't actually plunge underneath. So again, I can edit that tool path. I'm just going to put an inch in here. And then from that, we could go ahead and hit OK. Always get the tool path on your part. And as some of you are starting to realize, you have that edge selected. Guys, did I lose you guys? You guys still out there? Going once, going. I'm waiting for somebody in chat before I continue. Go ahead and let me know in chat if you guys can still hear me or if I disconnected again. Seems pretty common. Going once, going twice. Oh, still here. All right. Looks like I was buffering there for a minute. That's wild. I have myself pulled up on my other screen over here. Oh. Hey, can you guys still hear me out there? Hello, hello. Trying to troubleshoot what's going on here. Go ahead and let me know if you guys can still hear me or not. It looks like I'm still live. All right, we're going to go with this. Thank you guys in chat for letting me know I'm screwing up like always. I don't know what it is. I think it's my internet. For some reason, at this time on Fridays, this happened last week too. But I'm just going to ignore the error. Hopefully, I'm coming through clear on your guys' side. Great to see you guys out there, of course. Mr. Hillman, still here. Great. Awesome. Let's get back to it then. Hey, Cosman made it back. Cosman, you showed up an hour early. You might get a trophy for that. All right, so at this point, undercutting that dovetail, right? What I've defined so far before I was rudely interrupted, I extended that contour. I made sure I selected it in the right location. And now at this point, I'm going to go ahead and swap out my tool to a dovetail cutter, right? So again, I'm going to add in my tool. We have a dovetail mill here. By default, of course, you have all of your information as any other time. I'm going to go ahead and plug that in as 45. Of course, I get the warning, taper angle is too large for the diameter and the flute length. So let's work our way up, right? Let's go ahead and make a flute length of 1 inch, shoulder length 1 inch. And from there, the taper angle for the diameter. All right, let's go ahead and step the diameter up. And we're going to go ahead and step that up. And it looks like we are still having issues with flute length. So let's go ahead and plug that in a little bit more here. Woo! Maybe it would work 1 hour earlier time. It's very possible that it might be. This would be where it would cut me off, so I wouldn't have to like continue the last 20 minutes. So again, let's go ahead and keep working through this for the flute length. All right, so let's just make the flute length even larger, right? We'll get it at some point. Too large for the diameter still. I tell you what, we're just gonna cancel this. We're gonna do what old Fusion Phil says you should do. Is we're gonna go back. We're just gonna grab a dovetail, and we're not gonna mess with it because I'm gonna probably have to go in and change something anyways. But as you guys can see, the idea is still the same, right? We're going in, we're machining under that undercut. Now my dovetail is way too small. This is a massive part, but this is how you would still set that to get it down for whatever you're machining. Now, based on that information, when you go to multiple depths here, you do have the 45 degrees, but if you try to type in a negative 45 degrees, it will alarm out. So you can't actually go negative to step down underneath something. So it's almost a one and done type of scenario. Awesome. Any other questions out there from anybody? Any other curiosities? I did see another question come in from Steve. Steve, if you're still out there, it will pick your thread tool and give you a program. Yeah, 100%. Awesome. Any other questions? Should I go check the old support email real quick? Make sure nobody's messaging in for support. Blake, shout out again for the lovely beer that you picked up. Awesome. So, as you guys can see, although I've been on site training all weekend, a lot prepped for you guys. So I'm going to open this up to all of you. If you guys have any questions or anything in particular you guys want to see, feel free to let me know. In the meantime, should I just get to the normal of programming parts? We'll go ahead and give it a minute for you guys to respond in chat. I don't know what is going on with this thing. Are you guys getting buffering anywhere on your end? It's telling me over here that it's buffering a bunch. That's why I'm asking you guys. Trying to get my stuff pulled up on my other screen. Can we show how to set up tool, change position? Oh, there we go. All right, we're back on my other TV so I can see what you guys got going on. All right, that was for the thread mill guy, 100%. You can hear me, great. Can you please show how to set up a tool change position to view it in machine simulation, hide and hind post? So your tool change position by default in those post processors are actually your home position, right? So as you can see here, oh, I'm buffering now. And now I'm back. Let me turn that TV off so it stops hogging internet signal. Looks like the warning went away. Am I there or am I not? Guys, let me know. I'm having a bad time. Going once, going twice. Is this going to be 2 weeks in a row that we failed? Yeah, so we do use Zoho Desk. If you want to send any part files in, feel free to use that support email address. You could send your part files in or make any requests. So what I'm going to do is I'm going to grab this actual machine right here. Password again. I don't know what's going on with my internet. I'm about done with this. We're going to have a long, hard chat with the old internet supplier. There we go. You know what? I'm not going to be able to reset my internet right now. All right. Are we good? You know what it is? So I have a mesh network, and I think the node by me is dying because it messages me like once every 2 days to tell me it's offline and then it's back. The moment I've unplugged it now, it seems that my internet is stabilized completely. You guys let me know. Am I back? Am I up and running at 100%? You know what? I should probably check to make sure I'm connected to the right internet as well, right? Let me know, guys, in chat. Waiting for you guys. Am I back? Am I clear? Are we good? All right. Looks like we are back. There we go. All right. Paul's back. Mr. Hill's back. Awesome. Yeah, I think I have a mesh network, and I think that node is dying. Like I said, it tells me a bunch that it's connecting and disconnecting. All right. Back to Pavel's question. Pavel wanted to know about tool change positions inside of Fusion. Now, by default, if I go ahead and add in a machine here, which I did select this machine, let's go ahead and re-download this and, of course, drop the internet everywhere in my house again. There we go. So your default tool change position until they update things is actually based on the home position of the actual machine. So again, yeah, Ty, in this case, this mesh network is an old Google mesh. It's about 2 years old. And like I said, I don't think it's the DHCP settings for sure. It's what it is that node is dying. It's been doing it forever. But again, let's go ahead and try this one more time. Maybe I got to grab a different machine. Why are you not bringing this in? Did we discover a bug? We're pretty legendary for that around here. Let's go. You know what? Since she's going to be difficult this week, it looks like. Actually, I'm trying to think what machine I have that would have it already on it without having to grab the latest and greatest. Of course, now you got to save the target document. You can't just put a file in here and go, can you, right? Here we go. We are going to need more than one tool path. So you know what? Let's just, it's going to be one of them days. You guys ever feel like that? It's Friday, right? About to find out if I can face with a dovetail cutter too. There we go. All right, so we got 2 tool paths. We got a tool change. We're gonna go ahead and save our part file as we've done, and we're gonna pull a machine, hopefully from my desktop, so that we don't have to download it. Or, there we go. Finally. Okay, so your tool change position in the world of Fusion, go ahead and not show machine, there we go, is when we simulate this, it's based on the home position in the kinematics tree, right? So as you're gonna see right now, we're sitting all the way over here to the left. We go in, we do whatever we're gonna do machining wise, we go up, we go back to that position, right? And then we come back in with our other tool. In this case, I am way behind the curve on having everything set up. But you can easily edit that position on your end by editing the kinematics of your machine, right? So keep in mind, inside of your kinematics tree, you have your X, Y, and Z, and then you have your home position over here on the right. So as you can see here, we could set the home position using X, Y, and Z, and that is currently what uses your tool change position. Now, if you want to get super fancy with it, there is a way to do this inside of the post processor. Now, I will show you where it's at, but I am not going to be editing it at the end of the day. Sorry to break anybody's heart here. But that is going to be the thing that you can figure out on your end, or you could reach out to me for a private meeting and we could talk about it. So again, it's based on your machine simulation. There is going to be a section for tool changes. You could also type in, I believe it's tool change. Got to get far enough down in our program. But there is a specific block designated for a tool change position and where that is actually going to be. So again, you have function machine simulation. Again, walking through this, where that tool change position will be simulated from, all defined inside of here. Sports, you are on. What am I on? Well, on a bad day. That's what I'm on. But again, as you can see, Pavel, you can get inside of the post processor. What you're trying to do is, one, you could use that machine position to set your tool change position, or in the post, there's a specific section for tool change versus machine home if you wanted to move a table to a certain location. Stuart, regard sketch. If I create a sketch on a model with a really busy face, a lot of holes, press pull, it's a mess. Have you encountered that? Hard to explain. So keep in mind, depending on what you're trying to do when you're machining, right? Or you're designing, I should say, is if I press pull this face right here, there is a point, as you can see, when those surfaces interact and overlap each other. Now, this is a pretty simple drawing, but usually what's happening is Fusion cannot calculate the intersect of those surfaces. But Pavel, you said it's not working. Can you give me a little more information? And also my question to you would be is make sure you have the latest version of that post processor. So one thing for sure, Pavel, make sure you have the latest and greatest post. We could also scrub the list here real quick to make sure that that was added. Give me a sec here. I'll pull it up on my other window. Now, commonly what I see is people have a post processor that is outdated. In that outdated post processor doesn't have the latest and greatest stuff. So again, as if we go into Siemens, said it was, no, it was Heidenhain, right? If we look at the Heidenhain post here real quick, at one point, simulate connecting moves. That would be one that you need to find. It was removed because they've made that on by default, right? But where is it here? Connecting moves simulated is now enabled by default. If we go back a little further, there was probably a point where they added it in. But what I normally see on my end is somebody is, you know, like 4 or 5 post versions back, and they need to bring in the latest and greatest version because there is a lot of things that have been updated to actually make the post better and communicate better with Fusion. Let me go ahead and get chat pulled up. I saw you guys starting to bounce around in there again. You have the latest. So let's go ahead and jump back over and take a look here. So if I was to edit this and switch it out to the Heidenhain post, I'm just curious. We'll go ahead and play around with this here. Looks like I'm dropping in signal again for some reason, but I'm back. Good news for all of you out there. I'm going to be moving my office and hardwiring my computer. So we need to go ahead and swap post processors. Yes, I know this is still a Haas machine for those of you guys out there. But we need to demonstrate whether or not that Heidenhain post is going to do what we need it to do, right? Let's. Guys there? You with me? I think I disconnected again. I am hardwiring this computer this weekend. So Pavel is correct. So what I see here, Pavel, just so you know, it looks like when it does the tool change, it's not going to the home position for tool change, and we can fix that in the post processor as well. So I'll give you guys a second. I think I disconnected there and buffered again. Pavel, let me know when you're back in chat, and I can show you where to change that in the post. Or if you need to see it again, of course. In the meantime, I am going to fix this tool path and set it up right with a better tool. There we go. Much better. So again, as we were talking about there, if you guys are joining me again, obviously I need to just throw my whole computer away. So what I've done is I've just reused the same simulation. And as you can see, it comes from the home position right now. Now it's machining down my part, right? And then when it goes up to do a tool change, it's only retracting in Z, tool changes, and then comes back down, right? So it's not going home to do a tool change. And that's where I said we could fix that in the post. So when I go to post out, if I can click the right buttons today, we're going to go ahead and edit our post. And now what I tell most people to do is the Control F home. And if we go down a section of code, what we're looking at, home XY line, right? So you have on indexing, on tool change, or on program end. Now, what we need, and it says it over here, is you need to do a combination of things based on the way it's worded. It's just not a true false statement, because we could send just Y home, just X home. What I'm going to do is I'm going to highlight the X and the Y here, and we're going to go ahead and plug that in where that false is, and I'm going to hit save. And then if we go ahead and minimize our screen and we re-simulate this toolpath, it's probably going to make me show you guys that I'm a liar, and it's not going to work, of course, for me. But now when we go down after doing our toolpath, notice how we go back to our home position, right? Do our tool change and then come back in to machine our part. So again, based on indexing as well, you could do the same exact thing to always force it to go to wherever that home position is. So I'll have you out. And we're back again, it looks like it. I don't know what is going on. We might have to call this one short so I can figure out what's going on with my internet. Let me know when you guys get back here. Yep, so I am dropping connection quite a bit on my end. I am going to call this one this week, guys. I apologize. I know this is 2 weeks in a row that I'm going to ruin it for all of you. But given that I am having internet problems, I will make sure next week that I am hardwired in to my actual router so that we're not having these issues. And with that, I will leave you guys to your weekend. You know, it's not what you know, it's who you guys know. You know myself, Phil Brown, over here at jitcadcam. And I will look forward to seeing you guys next Friday, where my internet should be 1,000 times better. I will be testing it out as well to make sure that we're more than adequate for Friday afternoon live streams. With that, guys, have a great rest of your weekend.